Hello everyone, welcome back to my channel. We are going to prove that the left hand side is equal to the right hand side. So we start right away in our solution. Let us start from the left hand side. We say from the left hand side, log 6 of x is equal to, this one when I change the base and I introduce base 3, it is going to be log 3 of x divided by log 3 of 6, okay? But log 3 of 6 is the same as writing log 3 of 2 times 3, okay? And this one will take us to, it is taking us back to this law of logarithms, that if I have log a of b plus log a of c, the bases are the same, then I multiply the values, log a of b multiplied by c. So this is the law that I'm going to apply here. So let me rewrite this one here. Let me rewrite it. I will say log 3 of 2 multiplied by 3. We shall rewrite it like log 3 of 2 plus log 3 of 3. Okay? We also know that log a of a is 1. Okay? So log 3 of 3 is going to be 1. So I'm going to write log 3 of 6 will equal to 1, because I have, okay, let me first write this one, log 3 of 3 plus log 3 of 2, okay? But this one is 1. So I say log 3 of 6 is going to be 1 plus log 3 of 2. Now bring back our equation here, okay? We are saying that this implies that log 6 of x is going to equal to log 3 of x divided by what we've got as log 3 of 6. That is 1 plus log 3 of 2. And this is proved as required. Okay, we have this one. It is given that log 2 of x plus 2 log 4 of y is equal to 4. So we are going to show that xy is equal to 16. So in our solution, we have our equation log 2 of x plus 2 log 4 of y equaling to 4. Now we are going to look at this base here, this base 2, and we are going to introduce a new base on this second log, and we rewrite it using base 2, okay? So this is going to be log 2 of x plus 2 into log 2 of y divided by log 2 of 4, okay? This is equal to 4, okay? Now, you find that log 2 of 2, log 2 of 4, this is 2 squared, not so? So I will have log 2 of x plus 2 into log 2 of y divided by log 2 of 2 squared. Remember the laws of logarithms. This 2 is going to drop here, okay? So I will have, this is equal to 4, log 2 of x plus 2 log 2 of y divided by 2 log 2 of 2 is equal to 4. Okay, this 2 will go with that 2. Now log 2 of 2, we know that it is 1. So I will have log 2 of x plus log 2 of y is equal to 4. Now we recall that whenever you have the same base and there is a plus, you multiply the values. So I will have log 2 of x times y is equal to 4. Okay? Now we are going to rewrite this as an index, or we are going to take it back to indices. And we shall have this one, xy is equal to 2 to power 4. Okay? Then xy is equal to 2 to power 4 is 2 multiplied by 2 multiplied by 2 multiplied by 2. And I'll end up getting 16. So it is shown as required. So it is given that log 3 of x is equal to p and log 18 of x is equal to 2. Prove that log 6 of 3 is equal to q divided by p minus q. So in our solution, let us start with log 3 of x. Log 3 of x is equal to p. Let us take it back to indices. We shall say that x is equal to 3 to power p. That is our equation 1. Okay? Then we have log 18 of x is equal to q. Log 18 of x is equal to q. So I will do the same. X is equal to 18 to power q. Okay? When you're taking it back to indices, this value comes here, then the base remains the same, and then you raise it to this power. Okay? So this is equation 2. Okay? Now we have two equations, that is equation 1 and equation 2, where x is the subject. Okay? So I'm going to say equation 1, I'm going to equate equation 1 to equation 2. Okay? And I will write 3 to power p is equal to 18 to power q. Are we there? Now, you look at your question, okay? Our point of interest is in the base 6. So I'm going to introduce base log to base 6 on both sides. So I'll write introduce log base 6 on both sides. Okay? So I will have log base 6 of 3 to power p equaling to log base 6 of 18 to power q. Okay? Now you find that this power, by the power rule, it's going to drop to become the scalar multiplier of this log. So I will have p log 6 of 3 is equal to q log 6 of 18. Okay? 18 is the same as 6 times 3. Okay? So I'm going to rewrite like this. P log 6 of 3 is equal to q, open brackets, log 6 of 6 times 3, like that. Next, I will have, we go back to the first rule, the product rule, that if I have log a, m multiplied by n, this is going to be log a of m plus log a of n, okay? So I will have p, this implies that p log 6 of 3 is equal to q, open brackets, log 6 of 6 plus log 6 of 3, okay? P log 6 of 3 is equal to q, open brackets, log 6 of 6 is 1 plus log 6 of 3. Now you're going to distribute this q. P log 6 of 3 is equal to q plus q log 6 of 3. Collect like terms, it will come this side as a negative. P log 6 of 3 minus q log 6 of 3 is equal to q, okay? This is common, I'm going to put it out. Log 6 of 3 into p minus q is equal to q, okay? Now I will divide through by p minus q by p minus q, and I will have log 6 of 3 equaling to, because this one has cancelled out, q divided by p minus q, and that is proved as required, okay? It is proved as required.